Good morning, students. Today we are going to study the preparation of haloalkanes. So, we have studied what is meant by haloalkanes and haloarenes. There are 5 methods of preparation of haloalkanes. First method is from alcohols. So, CH3CH2OH, 2 carbon alcohol. 2 carbon means eth, so it is ethanol. When ethanol is treated with hydrogen halide, it may be hydrochloric acid or it may be hydrobromic acid, HBr, in the presence of anhydrous zinc chloride. The mixture of anhydrous zinc chloride and HCl is known as a Lucas reagent. It is known as a Lucas reagent. Or if you treat it with the Lucas reagent, it removes water molecule. Water molecule will be removed. So what is remaining? The remaining will be CH3, CH2X, where X may be chloride or bromide. Chloride or bromide. So the haloalkanes can be prepared. Then second method is the same alcohol is treated with the PCl3, phosphorus trichloride, or PCl5. These PCl3, PCl5 is known as a chlorinating agent. So here 3 molecules of ethanol. The 3 ethyl group will takes away 3 chlorine. Here 3 chlorine atom is there. So 3 chlorine is taken away by 3 ethyl group. So you will get a 3 ethyl chloride. So what is remaining? The remaining is 3 hydrogen is there, 1 phosphorus is there, and 3 oxygen is there. So the remaining here 3 hydrogen, this was removed. So 3 hydrogen, 3 molecules, 3 hydrogen, 1 phosphorus, 3 oxygen, H3PO3, which is known as the phosphorus acid. Phosphorus acid is the byproduct. So this is by PCl3, PCl5. When PCl5 will react, this ethyl group will takes away 1 chlorine. This hydrogen will takes away another chlorine. So what is remaining? 2 chlorine was gone. Remaining PCl3 is there. The PCl3 was taken away by this oxygen. So we will get 3 products here. We will get 3 products here. Ethyl chloride plus phosphorus oxychloride plus HCl. POCl3 is known as phosphorus oxychloride. Then SOCl2 is known as thionyl chloride. Thionyl chloride. You know that S stands for sulfur. So in organic chemistry, sulfur is called as thio. So thionyl chloride. This thionyl chloride here, once again the ethyl group will takes away 1 chlorine. This hydrogen takes away 1 chlorine. So what is remaining? The SO. The SO will takes this oxygen. So you will get ethyl chloride plus sulfur dioxide plus HCl. So here these are the 3 products you will get. 3 products you will get. So ethyl chloride will takes away this chlorine. In all the 3 cases, ethyl group will takes away this. Not only here also. The ethyl group will takes away that chlorine. Now the second method, free radical halogenation. Halogenation is a substitution reaction. Substitution, instead of hydrogen, 1 halogen will be substituted. Here you can see this is an alkane, 4 carbon alkane. 4 carbon alkane is what? This is butane. Butane. In butane, if it is treated with chlorine in the presence of UV light, then instead of 1 hydrogen, so this hydrogen, instead of 3 hydrogen is there, instead of 1 hydrogen, 1 chlorine will be substituted. So what happens? HCl will remove. HCl will minus HCl. 1 hydrogen, 1 chlorine will remove. In that place, another 1 chlorine will go. So here it's isomer. Sometimes this hydrogen, sir, why can this can able to displace this hydrogen? Yes. So if it displace this hydrogen, you will get CHCl, CH2, CH3. So this is the isomer of this one. Isomer of this one. This is known as 1-chlorobutane. 1-chlorobutane. This is known as a 2-chloro. Giving the numbering, this is known as 2-chlorobutane. So you will get 2 products here, 1-chlorobutane and 2-chlorobutane. This is substitution reaction. Similarly, what is the name of this compound? Benzene having 1 CH3. Yes, this is known as toluene. When toluene is treated with the bromine in the presence of iron as the catalyst in the dark condition. Here in the haloalkane, it is a light we need, UV light we need, but here dark condition, substitution takes place. So here 2 products we will get. So what are the two products you will get? So these are the two products. One is the nearby, the next position, the hydrogen is replaced by one bromine. Here one hydrogen is there, this hydrogen and bromine will go as HBr. In that place the another bromine will occupy or substitute. So here if two adjacent position, two groups are there, then it is known as ortho. So here you will get ortho-bromotoluene. Whereas two opposite position, or they will say this is 1-2 position, this is 1-4 position. If two groups are there in 1-2 position, it is known as ortho. In 1-4 position, para. So here you will get para-bromotoluene. You will get. This is the second method, that is free radical substitution. Why it is called as free radical? Because in the mechanism free radical will come. So we will study the mechanism later on. So it is called as free radical halogenation. Now alkene. So first alcohol, then alkane. From alkane we prepared. Then second one alkene. Alkene means a double bond will come. So this is an unsaturated compound. So unsaturated compound, normally which reaction takes place? Addition reaction takes place. Yes, addition reaction. Here hydrogen and halogen. Hydrogen will go to one carbon and iodine will go and attach with another carbon. So you will get ethyl iodide. Then unsaturated will become a saturated compound. Now this alkene is known as ethene. This ethene is a symmetric alkene. Symmetric alkene means if I put a line, both sides same group. But this is an unsymmetrical alkene. This is propene. Next one is propene. The propene is an unsymmetrical alkene. In the unsymmetrical alkene, so what will happen? Here, in two ways the reaction happen. Now the question is H plus I minus. Where the hydrogen, here only going to take place in the unsaturated compound. Where this hydrogen will go, where this iodine will go. So this hydrogen will go to the CH or CH2. That is a question. So here a rule called Markovnikov rule. Markovnikov rule or Markovnikov addition. What is Markovnikov addition? Negative part of the addendum goes to carbon containing less number of hydrogen atom. Negative part of the addendum. Addendum means adding compound. What is the negative part? Iodide. That will goes to the less number of hydrogen. Where less number of hydrogen is there? CH. So here the product you will get is CH3, CHI, CH3. This hydrogen will go and join with the more number of carbon containing more number of hydrogen atoms. So you will get the 2-iodopropane is the answer. Suppose, sir, I don't want a 2-iodopropane, I want 1-iodopropane. Then what you have to do? We have to put a peroxide. If you put a peroxide, then the reaction takes place in anti-Markovnikov rule. So in anti-Markovnikov way, negative part will goes to carbon containing more number of hydrogen atom. So here you will get CH3, CH2, CH2I. The reverse way takes place. Hydrogen will go to here and iodine will go here. That is anti-Markovnikov rule, or it is also known as Kars effect. So all this we have studied. We have studied Kars effect. We have studied Markovnikov rule in 11th class. Once again repeated here. This is the preparation of an alkyl halide from an alkene. Then last one, when an alkene is treated with the bromine in CCl4, bromine will dissolve in CCl4, carbon tetrachloride. It will treat it with bromine and CCl4, and both the places bromine will combine. So we will get CH2Br. We will get a dibromo compound. What is the name of this? 1,2 dibromoethane. 1,2 dibromo. Ethane is the name of this compound. It is already we have studied in the classification. Monohaloalkane, dihaloalkane. This is a dihaloalkane having 2 halogen in the 2 successive carbon. Okay. So this is the third method from alkene. Now fourth method. Fourth method is known as Sandmeyer's reaction. There is a name reaction. The name reactions are important. Sandmeyer's reaction. The Sandmeyer's reaction, the benzene having NH2, benzene having NH2 is known as aniline. This is known as aniline. So when aniline is treated with, when aniline is treated with the NaNO2 HCl, sodium nitrite and HCl, then we will get a product called diazonium chloride. Very important product, benzene diazonium chloride. Diazonium chloride. This is a salt. They will put N2 plus Cl minus, they will put, it is a salt. You will get a salt. So here the reaction takes place at very low temperature. 273 means 0 degree Celsius. So 0 to 5 degree Celsius, or you can also say 0 to 5 degree Celsius. In ice cold condition, in aniline will become diazonium chloride. Then benzene diazonium chloride. Benzene diazonium chloride. When it treated with copper chloride, we will get chlorobenzene. Whereas when you treat it with the potassium iodide, we will get iodobenzene. So this is the way how we are preparing the haloarene. What is haloarene? The benzene ring having a halogen. So the name reaction is Sandmeyer reaction. When aniline is treated with the sodium nitrite and HCl, then benzene diazonium chloride will obtain first, which are treated with copper chloride. Or we can say here, if you put X2, here you will get X will be chloride or bromide. So here benzene diazonium chloride, if you put Cu2 Cl2, we will get chlorobenzene. If you put Cu2 Br2, we will get bromobenzene. So chlorobenzene, bromobenzene can be prepared, whereas iodobenzene can be prepared if you put Ki. Then last method is a halogen exchange reaction. Halogen exchange reaction. There are two types. One is Finkelstein reaction. So here Rx treated with NaI. Then another one is Schwarz reaction. So CH3Br plus AgF. So here from one, see normally alkyl halide chloro compound, bromo compound will easily prepared, but fluoro iodo will somewhat difficult. Fluoro haloalkane, iodo haloalkane is difficult. For that the reaction is halogen exchange method. The halogen exchange method, you take alkyl halide, normally chloride, you treat it with the sodium iodide. So then you will get the iodide will form, then you will get sodium chloride, where if X may be chloride or bromide. So chloride can be converted into iodide by the name reaction called Finkelstein's reaction. Another name reaction, Schwarz reaction. The Schwarz reaction, if I put silver fluoride, then the silver bromide will precipitate. The silver bromide will precipitate. Then you will get a fluoro compound. Methyl fluoride will form. So these two are the halogen exchange reaction. So that's all about the preparation of haloalkane. There are 5 methods. I once again recollect. First method from alcohol. Alcohol is treated with the Lucas reagent, or PCl3, or PCl5, or thionyl chloride, SOCl2. Then we will get the alkyl halide. Then second method is free radical halogenation. Alkane already saturated. One hydrogen is replaced by one halogen by putting chlorine in the presence of UV light. Whereas if it is an haloarene means benzene ring, in the presence of dark condition, in the presence of ion catalyst, you will get a substituted product, ortho and para product. Then in the alkene, from alkene, if symmetrical alkene means it is very easy. Unsymmetrical alkene, there are 2 types, Markovnikov addition, anti-Markovnikov addition. Markovnikov addition, negative part of the addendum goes to carbon containing less number. So you will get a branched compound, 2 iodo branch compound you will get. If straight away compound you need 1 iodo compound means anti-Marconica, for that you have to add peroxide. Then fourth important name reaction. All name reactions are very important. Name reactions are very important. Sand-Meyer reaction. Aniline is first converted into benzene diazonium chloride. Then benzene diazonium chloride is converted into the chlorobenzene or bromobenzene or iodobenzene. Then halogen exchange. Normally fluoro compound and iodo compound can be prepared from the other alkyl halide. Okay. Thank you, students.